Welcome to Data Forward, the podcast that keeps you ahead in the fast evolving world of enterprise AI and data management. We bring you expert insights, actionable strategies, and the latest trends to help you stay on top. Ready to shape the future of data? Let's Data Forward.
Hello, everyone, and thanks a lot for joining us today. I am Vivek Singh. I take care of product marketing at Acceldata, and I truly appreciate you taking the time to be here with us. And welcome to this AMA, Ask Me Anything session with one of the world's foremost data platform experts, Mr. Chandrakant Sharma, fondly known as Chandra. This session is designed to be practical and valuable. So we'll focus on some of the toughest challenges enterprises face when modernizing complex data platforms, be it controlling cost, ensuring reliability at scale, and preparing to thrive in an AI-driven future. No theory, just real-world insights and proven lessons you can take back to your teams and start applying immediately to get results. So, data leaders today are under immense pressure to deliver more with fewer resources, migrate to the cloud, avoid vendor lock in, prepare for AI workloads, and in between all of these, keep their mission critical systems running flawlessly. But the reality is that most data platforms are still overly complex, fragmented, and costly, making it hard for enterprises to move fast and unlock their full potential. In this session, we'll cut through the noise and focus on what actually works in the real world, practical strategies that leading organizations are using to modernize and get real results. And that is why we have Chandra with us today. Chandra is Global Field CTO and VP of Field Engineering at Acceldata and works very closely with some of the largest enterprises on their toughest data platform challenges. Chandra brings a unique perspective shaped by years of hands-on experience guiding organizations through complex modernization journeys. Many of his recommendations have become internal best practice checklists for leading data teams, influencing how enterprises think about modernization, hybrid strategy, and platform reliability at scale. So, over the next 25 minutes, we'll dive into Chandra's perspective on what really working for data leaders today, proven strategies and hard-earned lessons that can make a tangible difference in how you run your data platform. We have prepared some of the most pressing questions we hear from enterprises every day, and we'll go through them one by one in detail. So if you have any questions, feel free to drop them in the chat and we'll take them at the end. So now the stage is set. Let's jump in. Chandra, thanks again for joining us today. You have had front row seat to some of the biggest and most complex data platform challenges in the world. But before we get into the specific, can you share where it all began for you? What's your story? What first drew you into this space and what keeps you motivated to help enterprises tackle this massive high-stake challenges every day?
Um, well, let's look back. So I think it was almost a decade and a half ago when I first started looking at data warehouses back when big data was still in its nascent stages. And big data technologies like Hadoop and its ecosystem components were still kind of taking shape. So the experience of looking at data at complex volumes at serving fast mission critical and business critical functionality for businesses which affect real life issues and provide resolution to a lot of real life issues for everyone across fascinated me a lot. Now, one of during one of the earliest data warehouses that I worked with, I was looking at a legal correspondence website, which basically is used predominantly in the US markets. It is a tool that is built for lawyers and judges across the US landscape, which basically dictates every courtroom decision and every courtroom expression that advocates basically make on a day-to-day basis at a scale of hundreds and thousands of courts that basically exist within the US and millions of lines which are passed as arguments every day, bringing in all of that data in less than 15 minutes when none of the new gen technologies actually existed was really fascinating. So from advocate's mouth to steno's keyboard to the data being available with references on the portal, it was less than 15 minutes of SLA. And it was tagged, it was cleansed, it was referenced, it was usable. And that was real time back then. And this is almost 2 decades ago. So that actually brought my attention to a number of other data related challenges that enterprises were facing every day, from real world products built on top of data to business decisions that relied heavily on data. Everything was growing extremely fast. The entire enterprise landscape was going through a transformation. Data was growing 5x, 10x on a monthly basis, and then it switched to the same scale on a weekly, and then later on to, as we all know, on a daily basis. The amount of data that we all produce every day today is just was not even imaginable 2 decades ago. And 3 decades ago, 3.5 decades ago, we were still working with floppy disks. So, you know, a huge transformation has taken place in a very short amount of time. And looking at everything that we do with data and what we could do more with data just keeps me on my toes every day. There's always something new to solve, something new to learn, some new mountain to scale.
Great. I think from working with advocates to becoming a data modernization advocate, that's great to hear your journey over the past 2 decades. So now coming to, over the years, you have seen data platforms change dramatically from the early days you mentioned about on-prem Hadoop clusters to the cloud wave, and now towards hybrid and open architectures. So, from
Mhm.
your vantage point with leading enterprises, what's really have driven these shifts? Like, and what's the biggest lessons you have seen, both the successes and missteps as organizations have gone through these transformations?
In the last couple of decades, at least in the data landscape part of it, if we talk about from a software or software management perspective, the two key things that have shaped decisions and roadmap for most enterprises, first being the big data ecosystem, which was built on top of Hadoop. Now, when Hadoop initially came in, it did bring a lot of opportunities with it, which resolved the most critical part of the problem, which was scale. Scale for that volume of data back in those days was a big problem because you could only scale linearly, and scaling horizontally was super expensive. And the data warehouse technologies that existed at that time just did not offer scale at that price point to businesses anywhere. And interoperability between applications were also very restricted. So you were always kind of confined, always kind of locked in, and that kind of slowed down innovation for a number of business units out there and enterprises globally. So that was the first big shift that happened. We'll get to the pros and cons of it as well, but that kind of led to the second wave of shift, which was kind of merged from an infrastructure standpoint as well, because all of these big data platforms initially were all set up on premise, which basically meant managing hundreds, thousands of servers with their own respective infrastructure modules and overhead for basically IT teams to manage these vast landscape of servers and storage farms to keep operating on that data scale. And that slowed um businesses down one more time because everyone thought that running a separate dedicated org, which was just looking at infrastructure all the time, and businesses wanting more every day, is kind of slowing them down overall. So they needed flexibility with management, where if not 100%, at least 80% of management parts became highly automated, and the overhead for management and the restraints with data center spaces and everything that takes to basically run a data center was basically offshored for them. So there were some models that existed back in the day where people leased data centers from other companies, but that was just not scaling enough for them. So that brought in the wave of cloud, as we know. That was the first step towards it. The second being the evolution of microservices architecture. People thought that, why not basically have an app itself running in the cloud, which is fully set up and geared and does not require all of the prep and prerequisites that are needed to set up a software solution and then start using it. So how do we make that happen? That became evolution part two within the cloud, where companies like AWS, or rather Amazon and Microsoft started offering all of these services, which made jobs for professionals a lot more easier. So you stopped thinking about overhead of setting up a service and you started thinking about how do I use this service, which was another significant shift. And the cost of it again became a challenge after a period of time. Now, the biggest problem that existed in the big data world was managing it, managing the evolution of it, the pace at which open source ecosystem evolved, and while it brought a lot of good things, it brought its own challenges, like the black box thing. Like you didn't know what was going wrong until you had a observability solution that told you which component was responsible for a failure, which did not exist back in the day, which led to a lot of businesses being disappointed, and in a few occurrences where it even caused production outages, etc., for bigger enterprises. And they kind of started moving all towards cloud, where someone else was responsible, someone who was more skilled, who was more used to the service, and they owned the SLA for the maintenance of the platform. On cloud, if you look at it, while everything is good and it is still evolving at its own pace, cost has become a big part of the problem, because on cloud, it is like a running meter. So whether you run the job once and it fails, or if you run the job twice and it succeeds, you still get billed all three times, um, which is kind of becoming a big bill to foot for a lot of these growing enterprises, considering they're paying for everything and it's not no longer a capex for them. It's kind of become an opex, where you pay for everything with the running meter. So we are looking at the next best thing, which is the hybrid architecture, which I think we'll be talking about in a few minutes.
Okay, great. So, despite years of efforts and huge investments, many enterprises still feel stuck. Their platforms are complex, costly, and not delivering the speed or agility they need. From where you sit, what's the biggest shift you are seeing right now in how data leaders are approaching modernization, especially with AI rapidly changing expectations for what these platforms need to deliver?
Right. See, I think we have to understand that the underlying part of it is that the definition of speed is changing, or it was changing earlier every 3 years. Now it is changing almost every quarter. What was basically an accepted standard in terms of data processing speeds 3 years ago from now is no longer a standard anymore. People want everything to be 10x faster. They want better control. They want to be AI ready. And basically, if you look at AI readiness itself, it requires your data to be ready to basically make AI work, which again is one of the biggest focus areas for most of the data leaders out there, are like the big banks, which are our customers, and big telcos, are super focused on two parts right now. What is the next gen architecture, which is cost effective, allows me to scale at my pace, which is faster than what, in context to the cost at what they get on the cloud. And third, it does not lock me in. Fourth, whatever I built in terms of AI, see a lot of these migration exercises that has happened in the last 3 decades, from data warehouses to data lakes to cloud lakes, etc., have all shown a good part as well as a very bad part. The bad part has always been that these migrations took a lot of time and effort, because whenever they moved data, there was nothing to certify that the data got in correctly, and the conventional tools were simply not enough. Secondly, the data sources itself were not kind of certified. So at times the data at the source originated incorrectly. Now, with AI and its requirements, the AI basically dictates tagging every certified data to ensure that the models run correctly and then they respond correctly as well. And that's where lies the biggest focus areas for all data leaders. even like you can bring in any model uh, into an enterprise at any given day. Like there are paid subscription that you can bring in. There are open source models that you can just set up and start working with them. But the key fact is once you start building it up against incorrect data with insufficient scale and speed, it elongates your path or your journey to success, which leads to more failures and rework and cost overall in most cases than not. So key parts in a quick summary. First is to ensure that one, they have a ground up architecture from an infrastructure perspective that allows them to scale at their own pace and with their own requirements. Two, the data against which they want to be AI ready must be certified and correct so that their models do not hallucinate, do not give them wrong responses and point business in incorrect decisions or incorrect directions, rather. And with that, you get a base layer ready, hand in hand, that allows you to then build on top of it and become AI ready.
Okay. Sure. So now that we have heard Chandra's journey and his perspective on how data platforms have evolved, let's get into what I now everyone here really wants to learn. What they can actually do in 2025 to unlock the most value from your data platform investments across the many enterprises Chandra works with. A few tough challenges keep coming up again and again. These are the ones that slow down progress, drive cost up, and keep organizations not realizing their full potential of their platforms. So in the next part of the conversation, we'll focus on the top three challenges that matter most, the ones if solved create the biggest impact. We'll go through them, each one of them one by one, and hear what Chandra is seeing in the field and get practical solution you can take back and start applying right away. So let's begin with the first one. Okay, so let's start with the challenge we hear all the time: complex, fragmented data stacks. Most large enterprises end up with dozens of tools, disconnected teams, unclear ownership of data pipelines. This slows everything down and creates reliability and quality issues that are difficult to fix. Chandra, when you step into this organizations facing this kind of complexity, what approaches have you seen work to simplify their platform and start unlocking real value?
Right. So basically, a general thumb rule approach that has helped me all these years is to put out the small fires first because there is fire everywhere. So whatever you can tackle as a lower hanging fruit kind of helps because you get to some of the easy wins and successes early. That actually helps speed up and propel things. Now, when we divide these problems into their respective categories, what you end up with is one, are there duplicated efforts that are happening? Is there fragmentation of data, or is there fragmentation of the applications that are trying to process this data? Or if if this fragmentation is being attained because of the underlying infrastructure limitations on top of which data is being processed. Now, duplicate efforts can also be in terms of fragmentation, but they can also be in terms of data being replicated to make itself available across layers and across landscapes. So we try to identify what is what and then help teams get rid of fragmentation in their data, in their architectural landscape. Now, there is also inconsistency. There is challenges with frequent outages. There is delays with most teams that they basically encounter, and some teams basically face the biggest challenge of innovation. Like they do want to do a lot, but their current tech stack and infrastructure and architecture limits them from doing any significant innovation at the pace at which they want to operate on, which is very stifling for a number of the teams, and that kind of keep teams held back, which impacts business in the long term. So if you look at um, what we generally approach with in terms of solution, like any other problem out there, whether you like if I have to give an example, like if you went to a doctor and you said, kind of my tummy hurts. So a good doctor always will first get you tested. He would try to observe as to what is happening with you. He'll ask you questions. He'll try to put you under a scanner. I don't know, but that's what we do as step one. We first recommend our customers to basically observe, not monitor, because every enterprise has monitoring already enabled and enabled for a very long time. They see what is up, what is down. They get infrastructure, telemetry information, and everything. But when you talk about observability, it is a step above from monitoring. It's not just about uh, getting a pulse beat or a temperature check on your systems. It's about understanding how things are moving, where it is moving from, what are the various blockages that are happening within your data pipelines, what are the limitation factors that exist between your current scale challenges that you're facing versus where you want to be, whether it's with regards to the software stack, whether it's with regards to the underlying infrastructure, whether it's with regards to the applications, whether it's with regards to the data model or the data layer that basically exists. So we help identify and basically report problems as the first step. And then we bring in a clear framework that allows them to remediate for these problems. Now, every problem has their own fix. So if the problem exists with data, we approach with a data reliability solution. If the problem exists with the software stack or the data platform itself, um, and that has been limiting them, we do have a data platform offering as well that helps them unblock things without being locked in, which is a completely open source distribution that we offer globally. And then there's also part where an architectural shift is required. Now, for enterprises, architectural shifts are not easy because a lot is already riding in terms of business decisions and business support on the current platform. So that becomes a slightly lengthier journey. So we progress with smaller fixes. As I said to begin with, we were recently working with one of the top five banks as our recently onboarded customer, where their biggest challenges were with the underlying infrastructure itself. They were simply not getting sufficient IO throughput for their data layer, and everything was slowing down. They had unexpected failures, um, and that required a complete recall on the infrastructure part of things. But what we did in the interim, because again, in a data center kind of a setup, or even in cloud, switching gears on the infrastructure side is not extremely fast because there's a lot that's already set up. We took baby steps at the beginning, started with tuning parameters and configurations, identified their data skewness problems, helped them remediate skewness, and um, step by step, we reached to a point where we had the required infrastructure fixes also available in place, and now they run seamlessly. So, yeah, it is a journey, and we start by first identifying what's actually happening under the hood.
Great. I think start with the low hanging fruits first. Okay. So another big challenge we hear constantly is vendor locking and skyrocketing cloud costs. Many enterprises start with the promise of flexibility and savings in the cloud, only to realize later that they are locked into a single vendor and losing leverage over pricing and innovation. Chandra, what strategies have you seen work for organizations to break free from lock in and truly take back control of their spend?
Right. So I'll talk on the spend part first because that is definitely one of the bigger problems to address. Now, when it basically comes to remediating for spend in an enterprise setup, and as I was telling earlier, is that cloud is expensive. It's a running meter, where even failures are costly. Um, what people had already tried in the past and were not successful because of the limitations of the technologies back in the day is something like a hybrid architecture or independent scaling architecture, which is completely decoupled. Now, in the past, when people tried doing decoupled architecture with ecosystems like Hadoop, they did not achieve the same level of performance as they did with a coupled architecture where storage and compute were co-hosted. Also, when they tried to leverage a hybrid architecture, the network limitations that basically existed between their own data centers and the cloud kind of prevented them from effectively scaling or performing at speeds that were required to support the business functionality. What has shifted in the last 3 years is that now we have technologies and infrastructure and hardware and software available that can overcome those boundaries and limitations. The network scaling problems have been remediated significantly. There is now software available, which is from out of the box itself, hybrid enabled, which basically means that it can run anywhere and everywhere. The evolution of technologies like Kubernetes and containerization has effectively provided a drop and run framework to enterprises across the globe, which was earlier still in its nascent stages. And there was a lot of complexities involved with it. There were security related challenges, governance related problems, etc. So all of them have been addressed significantly to a degree where it is now freely usable by enterprises. So they can leverage the part of containerization to its fullest extent from a compute perspective. And storage layer has become more consolidated with high performing NVMe disks and with technologies and enterprises now being offered the ability to run components such as NVMe Fabric has given them a singularized layer of storage, which can now scale independently compared to the compute layer that basically exists. So technologies like this now provide an alternative to enterprises, which can then be applied by them to scale independently and not just be restricted on cloud or not just be restricted on a data center either. They can go both ways, and they can use a mix of both worlds to its fullest advantage. The second part to your question, or actually, which was the first part, but I'm answering it in reverse order. Um, is the part where vendor lock-in still exists for Hadoop ecosystem-based distributions, which, in my own personal view, is a bit limiting from the perspective that open source projects are kind of built by global developers and contributed to by people across the globe. There's a lot that goes in to make that into a distribution, but then it is still kind of open source. But with vendor lock-in, what ends up happening is that enterprises are restrained by the release of these distributions. There is very less flexibility to try out different open source components. There is also challenges with the forced upgrades that most of the customers are prompted to do because someone else has moved ahead. And even though they do not want to move ahead, they are kind of forced into an upgrade path. There's also limitations in the speed at which vendor locked in distributions basically evolve because of at the pace, because of just the pace at which they kind of move in. So this is again stifling for growth. And that is where I think where we've helped most of our customers in the last 3 years is since we release our own completely open source distribution, is that there is no vendor lock-in with that. Customers have the option to have full access to the source code and evolve the source code as they see fit. They have full technical support and certified suite of open source products, which are security friendly for their infosec teams. So it is like getting the best of open source without having the overhead of building it or compiling it or maintaining it yourself.
Okay. So yeah, no lock-in. So finally, coming to the last, the third. Finally, let's talk about one of the toughest problems we still hear from enterprises everywhere, like Hadoop. So even though it's aging, expensive, many organizations are still running mission critical business defining workloads on commercial Hadoop. But moving off, feels very risky. Potential downtimes, data loss, breaking key processes. So they delay year after year. And while the cost keeps climbing up, the innovation stalls. So based on your experience working with some of the large and most complex Hadoop environments, what does a smart, safe migration actually look like? How can data leaders de-risk this move and finally modernize successfully?
I think what I have seen is that key to a successful migration is basically rooted in observing what needs to be migrated first. So when we help our customers move off of their current paid Hadoop distributions, we first basically set up our observability tool in their ecosystem to understand what is their current landscape right now. Now, you know, almost every team out there maintains detailed information about how much data they have, how much infrastructure they have, how many jobs are running, what type of jobs are running, and so forth. So they do have a lot of that metric and telemetry about their own clusters. But again, monitoring versus observability. What observability is all about is observing how all of these things are being utilized, what are their current limitations, and kind of flagging first that if they are to move away from their current distribution, what things should be addressed or planned ahead for before you even take a step towards migration. So that has been, I think, our magic sauce to success. We have migrated almost 250 clusters by now, which is approximately 400 petabytes of data all put together, some 45,000 servers in production of all shapes and sizes. So, and across banking, across telcos, across fintech, across healthcare and health sciences, highly regulated, highly scrutinized clusters. And we've always been successful. So, the solution that we offer does offer three lanes to migration, from in-place upgrades to parallel build and migrate like a forklift, to sidecar upgrades. And based on what SLAs we need to adhere to, uh, we basically set up our observability solution and work with our customers to plan for the migration. In fact, if I'm to quote some of the recent projects that we've done, we kind of spend the maximum amount in planning than execution. So we spent 3 weeks in planning, ensuring every job, every query, every dashboard that the platform supported. We accounted for everything and what it runs and its complexity before migrating the customer. And the migration was done in 8 hours. And it was a 400 node cluster. So we ensure that we basically check for everything and anything that can be a gotcha moment during the migration or after the migration. And that just helps us to be successful, like 100 out of 100 every time we've migrated there. We've never done a rollback because our customer never needed to roll back after they came onto the new platform.
Well, amazing. I think 100% success rate, the data leaders, it's a lot of reassurance for them and, peace of mind for them. So there you go. So these were like the three biggest challenges we see repeated across large organizations: complexity, vendor locking cost, and struggling with aging Hadoop, along with, the other proven strategies we see. So we have covered a lot of ground here, and I hope this sparked some ideas you can take back. But now it's your turn. Like, we'll take questions from the audience. So I think bunch of questions are already coming up. So we'll quickly take them. So Chandra, just consider that this as a rapid fire round. So we'll just quickly ask question, and top of the mind, few words or sentence you have, you can just answer them. So let's begin with the first. So, what's the biggest modernization mistake you see enterprises making repeatedly? Something every data leader should avoid.
Um, okay. I think modernization is definitely a key ask, and it is much required as well. So there is definitely a need for it. But treating modernization just as a pure play technology upgrade is rather short-sighted, in my view. I think this needs a more holistic picture. And enterprises, while they do plan for business as usual activities and they try to keep, one eye towards what this is going to enable for me on the next iteration of things, whether it could be getting ready for AI or implementing AI in itself. There is also need to isolate and have clear lines with business outcomes um, before attempting any, rip and replace kind of a migration approach. There is always a value-based and a phase-based path that enterprises should consider. Um, of course, while considering that, there is also a pace at which you can take the phase-based approach. Uh, most most enterprises do think that, a phase-based approach basically means a year-long, 2-year-long kind of a project, but it's need not necessarily be. See, with the tools that we have now, you can try fast, fail fast, and fix fast, much faster than we've ever done that in the past. And that in itself enable enterprises to just evolve at a faster pace with least business risk possible. And as I said, a key to basically diagnosing or migrating or upgrading anything is to first understand what is the state of systems today. And when I say understand, we basically mean a deep insight into everything that is happening and not just, a tunneled view of what is basically running right now. Um, the last thing I think every enterprise should consider, and I think they do consider it, but I'm just going to call it out, is to not carry baggage into the new architecture, right? So when you're doing a new architecture, and you do want to have business as usual, there is a tendency to kind of carry things as in. But then even that can be faced. You can bring in your existing Spark 2 jobs into your new platform, but there should always be an effort to move towards a later version of Spark. Just throwing out an example out there because we kind of did this with a customer very, very recently, which was running an old distribution of Hadoop, and they had a lot of Spark 2 jobs. The only reason they have not had any chance to migrate so far was because they were stuck. The engineering team that built all these jobs kind of moved away or left. Um, and there were a lot of investment decisions that the company had to make before they decided to upgrade everything from Spark 2 to Spark 3. There's confusion about should we go into cloud native technologies? What is the compliance limitations of that? And people were trying all across the board, but to kind of get to the part where how easy or how it would be to move from Spark 2 to Spark 3 kind of a thing. So I think we should address things a bit more directly and transparently, and we help them kind of move away almost 98% of all of their jobs from Spark 2 to Spark 3 in less than a week. Because we understood their code base. We looked at their jobs and their job design through our observability tool and found that that migration path for them was very, very easy. The 2% needed a very small amount of effort from their engineering teams to kind of upgrade. We knew exactly what static blockages they had, and fixing that was super easy. So they're on their way to 100% handoff now.
Okay.
Sorry, that was a long, lengthier answer to your smaller question.
I think, yeah. So now that's great. So now just, rapid fire round. So we'll just like a few words and then, so if you could just recommend one focus area for data leaders in 2025 to deliver fast, measurable impact, what it would be?
Um, I think the most key thing to do to set the baseline right, to understand what's happening within the ecosystems, is to set up for observability if you've not already done so. And when we say observability, it does not limit to your infrastructure or the applications that you run on top of your infrastructure, or the platform that basically enables these applications. It basically means all verticals, including data and everything that is happening within your data pipelines as well. So, a clear path and understanding of your data, its pipelines, its applications, its platform, and its infrastructure is kind of a must-have, because without it, you're kind of shooting in the dark, and there's a good chance to miss. And when companies miss, it leaves a pretty significant dollar dent on that miss. So let's try to save that. Um, the next part of it, I think, with everything that has been going on, I mean, from the perspective of how to deliver fast and ensure that the impact is at a scale that kind of helps propel things forward, um, is to kind of have a robust architecture, which is good to replace their existing limitations of their current Hadoop distribution, um, but then sets them up for an ecosystem which is not locked down from the perspective of how to innovate or how to grow and things like that. There is this very common misunderstanding that open source and Hadoop are the same thing. And a Hadoop distribution is basically limiting because of the components that build the core of it. That is actually not the case, right? When we talk about Hadoop, and if you were to look at it particularly, yes, Hadoop is an open source component, but not all of open source is Hadoop, right? So Hadoop basically comprises of three key main parts: a file system, a job processor, and a resource scheduler. So it's HDFS, Yarn, and MapReduce, and that's Hadoop for you in a nutshell. Whereas if you look at open source in total, there are a lot of other components in open source which have the ability to work completely independently of Hadoop. And our recommendation to our customers is to basically evolve beyond Hadoop as much as you can. And the traditional structures and limitations of Hadoop. Like, let's say, for example, you're using an HDFS file system today on your Hadoop cluster. Now, HDFS at certain scales has its own performance related limitations, regardless of how much hardware you throw at it, and depending on what version you're running as well. Some versions offer you a higher ceiling, some don't. But let's say you're on the latest, you've got all the hardware in the world, but you'd still hit a ceiling at some point or the other. So how to scale out of HDFS then becomes a question. That is where I think the newer bridges such as S3 protocols and ADLS v2 protocols and GCS protocols help bring in object storage to on-premise, or even go beyond on-premise to a cloud kind of an approach directly from these independent components. Like, for example, if you just wanted to run Spark, there is no need to have Hadoop today. The Spark that we basically ship is completely Kubernetes enabled, it's completely Docker enabled, it's completely Yarn enabled as well. So it supports legacy as well as modern compute and resource architectures. And so does a number of the other components that we basically offer. Like, we offer Trino as well as part of our open source distribution, which basically has the ability to run queries across the board for varied data sources, which are not even Hadoop centric that much. We also offer systems like Pino, and we're soon to offer systems like ClickHouse as well. ClickHouse being the most advanced real-time engines that exist today for OLAP. I think it's brilliant. We use it a lot in a number of our products and SaaS offerings that we have, and we it's just performed phenomenally for us. So if you look at our distribution overall, right, it's not just Hadoop that we offer from an open source perspective, but we offer open source itself, which is enterprise ready, which is very different than just running Hadoop. But you could still run Hadoop as well if you wanted to. So it's like you have the best of both worlds there.
Okay, so Hadoop and open source are not the same. So, next question: how do you design a platform today that's truly AI ready for the next 3 to 5 years, given how fast the technology landscape is shifting?
Um, so if I have to think ground up, um, and if I have to think scale, the first and the foremost, the building blocks of that should be the architecture of my infrastructure as well, because on top of it, everything else is going to be built. And that needs to be built for scale and speed. So at bare minimum, what we would look at is a decoupled architecture where I could scale on CPUs, I could scale on GPUs independently of how my storage scales, which basically means I'd be on the lookout for an object storage solution on premise because I do want to keep my storage centralized and highly performant for all of the different type of workloads that I'm going to run. And I do not basically want to have any giveaways on speed and performance when it comes to the accessibility of my storage device, because that's where I'd be interacting with the most. Um, from a compute perspective, as I listed, I design for not just CPUs, but GPUs as well, because there are a lot of things that are evolving at paces where you could use GPU horsepower to run a number of your current workloads much faster than they've run ever. So that delineation will become the building block of the platform itself. The second thing that comes after you've sorted for your infrastructure is the part of your platform as to what platform are you going to run? How are you going to define your resource scheduling for various types of workloads that you're going to run? And actually identifying what various types of workloads we are going to run as well. So, are we going to have a centralized kind of a setup? Are we going to have a hybrid kind of a strategy? So, that demands a platform to be chosen which has flexibility to work on both fronts without jeopardizing on stability or robustness. It also warrants you to be vendor free so that you could use the components that you want at the pace at which you want without having to be locked in, or actually taking the risk to run open source all by yourself as well. Because you need software which is auditable, which is enterprise ready, which is security free, and that kind of puts a whole list of work items on your bucket if you're trying to do all by your own. So choosing a distribution which is correctly supported, which is certified, is going to be the next part of the solution for me. Once you have the building pillars available and designed for and accounted for with their scaling strategy and roadmap and everything, it then becomes a question about how are we going to basically build the next set of things? What technologies do we want? What are the areas in which we want to innovate on? How to implement security, governance, observability, reliability on it. Because once you have the platform ready, the data is already starting to flow in. You need to be operational. You need to think about day two operations, how to maintain business continuity and run business as usual once systems are live. And tools, around your data and your compute observability becomes vital at that point because you want to keep the lights on, you want to keep systems optimal, you want to continuously tune for performance and stability and reliability of the systems, both from a platform as well as a data perspective. So that becomes the third most critical layer. And everything else on top is pretty much based on demand kind of a thing.
Okay. So, from your experience, what separates enterprises that succeed in modernizing their data platforms from those that stay stuck?
I think that is that is a very good and a tricky question. Actually, it is for some enterprises. I think they are limited by their options at times, um, and prioritization as well. I think for businesses, prioritizing modernization at a certain scale with a certain speed is not a very easy option to go with, which kind of delays things. There is limiting factors from an execution perspective, from a decision making perspective. I think for most enterprises, they do know what is the obvious thing to do. Uh, they do, however, have to be risk savvy from the perspective of, is this another bubble that everyone is talking about, or does this has a real chance to succeed, and how it is going to work out for me? And with modernization, there is a lot that kind of remains uncertified for them until a certain degree is basically achieved from delivery and success point of view. So I think for enterprises, with limiting factors as such, the best part is to approach with a phase-based solution where they prepare themselves to be ready for innovation before getting to the actual part.
Okay. So now we'll take the last three questions. So for enterprises still stuck on commercial Hadoop, what's the one step they can take today to reduce risk and start their migration journey?
They'll call our sales team. So, sorry, I had to slip that one in. But no, on a much serious note than that, you can actually visit a lot of material online on our websites as well as publicly available information, and look for first getting in an observability solution that allows you to understand your landscape to a depth and allows you to de-risk a migration path for you. That is the most critical thing. Once you've done that, then there are several options a customer can take. There are more riskier options that are available, and then there are more safer options that are available. It's up to one's appetite to choose which one they want to go with. Um, uh, I've worked with enterprises who build their own Hadoop distribution. We, as a company, consulted with them to help them design their own in-house platform as well, and how to basically go about building open source. Um, and we have actually built our own distribution, which is absolutely free, which is already certified and um, just ready to be consumed. No licenses required, no contracts. You can simply download it and run it. So,
Great.
easiest option.
Okay, open data platform. Sure. So, how do you recommend data leaders build internal alignment around modernization initiatives, especially when so many stakeholders are involved?
Right. I think hmm, it should always be driven by business and business outcomes. As far as there is a clear line of sight to business outcomes and what it is going to enable for their businesses, it makes it a very easy conversation to get stakeholders in the same page as the data leader itself. Um, I think if every migration or upgrade or modernization journey has clear ties to the business outcomes that it is going to deliver and drive, and the state of change that it will bring about, and the success that it is going to enable, then it kind of becomes a very easy decision to be done, because it's no longer why I should do it. It's about when I should do it and how I should do it. So change the question.
Sure. So, coming to the last question, if you had to give one piece of advice to data leaders listening today to future proof their platforms for the next decade, what would it be?
Well, a decade is a too long timeline based on the speed at which everything has been changing. Um, what I mean, from a thumb rule perspective, the awareness of one's own ecosystem is most critical. So again, when we see awareness, it's not just about knowing your landscape from the perspective of telemetry. It is about truly understanding what's happening everywhere. Have an observable and understandable, consumable insight of your data landscape. That is the most critical part, I think. And that is something that you're going to need even when you are AI enabled, not just, in the process of becoming AI ready, because everything requires you to have complete awareness of systems that you're basically running. Without it, it is going to be kind of the old Hadoop era, where People were operating massive platforms, but whenever something broke, uh, all hell broke loose, and everyone was kind of running pole to pole, trying to understand what caused the failure, what caused an outage, how to fix it, which logs to look at, and all of that. So I think starting from the baseline, having a solution that allows you to understand things in all of transparency, and does not give you, or actually allows you to shine a light in within the black box of your data ecosystem, is the first step, I think. And that is the first step, which is going to remain the first step for the next decade. Outside of that, preparing for ecosystems which do not lock you in, which gives you a leverage from the perspective of how you want to change, when you want to change, which directions you want to take as a data leader, because things are changing very, very fast. And again, not being confined by limiters like just Hadoop, but switching gears into ecosystems which are flexible, which are data center ready, cloud ready, and hybrid ready, because the next era of compute will be pretty much all over the place. So decoupling your dependencies, running parallel lines of compute and storage is another critical thing from an architectural perspective. But majorly, having a stack that basically supports that, and that stack should not lock you in either. It should continue to evolve beyond the traditional and confined spaces of legacy Hadoop.
Great, amazing. So I think that was great. We unpacked so much, so much of your years of experience and so much, your hard-earned lessons. So thanks a lot, Chandra, for joining us. And I'm sure everyone here is walking away with some practical ideas, they can take back to their enterprise, take back to their team, and start applying right away. And thanks a lot for all of you joining and being part of this. We truly appreciate your time and look forward to seeing you in future AMAs. And have a great day ahead. And thanks again. Bye bye.
Thank you, everyone, for joining. You too.
Welcome to Data Forward, the podcast that keeps you ahead in the fast evolving world of enterprise AI and data management. We bring you expert insights, actionable strategies, and the latest trends to help you stay on top. Ready to shape the future of data? Let's data forward.